Hi, my name is Randall Barney, Membership Director for the World Teleport Association. We're here at CommunicAsia 2015 speaking with industry leaders about the important issues facing the industry today.
Well, the two things that we are very aware of at the moment, Randall, is obviously the changes in bandwidth and also the changes in modulation. Now, for ETL, that's actually quite fortunate because we don't need to get involved in that because we are just carrying that signal. However, those technologies and those changes for the decoders and the encoder suppliers are very important because it means our equipment has to handle those signals extremely well, and therefore we are trying to design equipment that provides a very good RF performance, which is very high signal level handling and very good return loss and flatness across band to be able to handle these new signal qualities and modulation qualities. Okay, well, it very much linked to the changes in bandwidth and modulation that I've mentioned. What we're seeing is a mindset change in the way that RF signal chains are designed. What we want to be in a chain within a teleport between the satellite dish and the modem on the downlink is invisible. Our equipment is something you just don't need to worry about. So what we've found, one of the projects that we've found has been a real game changer, is a new design of alto amplifier which gives a very high signal linearity, low noise, very high gain, and it really means that we can now offer much better signal handling for satellite signals coming into the teleport. Now, there are two things that are important about that. It means that that technology requires very high mean time before failure and mean time before repair levels, and that is all down to good quality components. So really from an innovation point of view, it's the component sets that we're using now in an RF chain that means that mean time before failure has gone up and the quality of the signal has gone up as well. Something that we've looked at recently is a project where we've been asked to design a passive redundant matrix. Going back to a theme about single points of failure and redundancy, these are things that we are seeing a lot in people's teleport designs as they add new dishes to bring new signals into the teleport. So what we've seen is, again, a new amplifier range, the alto, where you have a main and standby signal, and you're able to monitor the performance of that downlink on the input and also on the output. And in the event of failure, you have the ability to automatically transfer that signal over to standby paths. And those sort of things give the teleport operator a lot more peace of mind. And as a manufacturer, that is sort of our remit. Again, going back to my original answer, it's about ETL being invisible and trusted in a teleport rack. Over the next few years, what we're going to see a lot of, and what we're seeing is innovation in build quality. One of the areas that we've got into over the last year is a very open system, RF over fiber. We hadn't addressed this area before, and we've started from a ground-up design to introduce a whole new product range onto the market. I've got one of those modules in my hand at the moment, so you can see here we've taken a common garden RF over fiber, completely redesigned it, rehoused it, and it's basically put into one box, and it means that we can maximize rack space within the teleport. So that technology allows the pressure on rack space within teleports to be reduced. The second thing that we're seeing a lot more of is the interference reduction group, which I think will play a big part in the quality of signals that are being sent up to satellites, because obviously this is of great interest to our satellite operator customers, as well as our modem customers that we're linked to. So we will be very much involved in the interference reduction group's work over the next year or so.